Hi friends, welcome to the YouTube channel of ChemLover. So today in this lecture we'll discuss Ritter reaction. This is a very important reaction for CSIR NET, GATE, MSc and IIT JAM exam point of view. Later on, after discussion of the mechanism of the reaction, we'll solve certain questions based on this concept. These will be the most important and expected questions for your coming exams. So let's start the topic, that's Ritter reaction. So topic is Ritter reaction. It's a name reaction. Basically, I have started the series of name reactions over here. This is one of the name reaction, that is Ritter reaction. So in this Ritter reaction, our substrate is, so what is the substrate in this reaction? Substrate in this reaction, it may be our tertiary alcohol. It's tertiary alcohol. Tertiary alcohol or alkene is the substrate. Tertiary alcohol or alkene, it is the substrate. Means we have alkene or tertiary alcohol. We convert this alkene or tertiary alcohol into substituted amide. So this alkene or tertiary alcohol, it's converted into N substituted amide. The product of the reaction will be N substituted amide. N substituted amide is the product of the reaction. Now how it's converted, how this alkene or this tertiary amide, it's converted into N substituted amide, means what is the reagent in this reaction. So the reagent in this reaction is, we have to make use of nitrile, that's RCN, nitrile, in slightly acidic conditions, that is we may take use of H2SO4. So H2SO4 is used, which will provide me H plus, that's proton source. A proton source is required, which is provided by this H2SO4. Now let us discuss the mechanism of the reaction. So first we have a tertiary alcohol. This is our tertiary alcohol. This is our tertiary alcohol. So this tertiary alcohol, it's treated with RCN, that's nitrile, alkyl nitrile. This is our alkyl nitrile in acidic medium, that's in presence of H plus. This H plus is obtained from this H2SO4, a proton source obtained from sulfuric acid. So in this reaction we get the product, that's N substituted amide. So what will be the N substituted amide? Our product N substituted amide will be this N, and we have amide group over here, double bond O and R. Now let us discuss how this product is obtained. That's what I am going to discuss. That's mechanism of this reaction. Now let me discuss the mechanism of this reaction. So how the reaction takes place. So first we have this tertiary alcohol. This is our tertiary alcohol. So this tertiary alcohol is treated with acid, that's H plus. This H plus is obtained from H2SO4. Now since there is lone pair of electron present on this oxygen atom, this oxygen gets protonated. So once this oxygen gets protonated, we get this type of structure. Since lone pair of electron on oxygen attacks this proton, therefore positive charge is generated. Why we have protonated this oxygen atom? So as to make this OH as a good leaving group. Since OH2, that's water, it's a very good leaving group. So it will leave, we get a carbocation. So generation of carbocation, the intermediate in this reaction, that's carbocation. So carbocation has been generated in this reaction. This was step first, that is generation of carbocation by the treatment of this tertiary alcohol with sulfuric acid, that's with proton. This proton has been obtained from sulfuric acid. Now in the next step what will happen, this carbocation, it will react with nitrile, that's R C triple bond N. Now we know that there is lone pair of electron on this nitrogen atom. This lone pair of electron acts as a nucleophile and attacks on this carbon. So what we are going to get, we get this type of species, since nitrogen attacks, and this is our triple bond C and this is R. Since lone pair attack takes place, therefore positive charge is generated on this nitrogen atom. Now what will happen in the next step? In the next step, what will happen? This bond will break towards nitrogen atom so as to neutralize this this positive charge, and carbocation is generated on this carbon. So what we are going to get? We get an electrophilic center. So over here we are going to get an electrophilic center. Sorry, this is our carbon. So on this carbon an electrophilic center is generated and we have R group. Now what will happen? Since in the reaction medium this sulfuric acid is aqueous, so we have plenty of water available over here. So attack of water will take place. Water contains a lone pair of electron. So lone pair of electron on oxygen atom takes place on this. So what we are going to get? We get this type of species. This is our carbon. On this carbon, attack of water takes place and we have R group. Now in the next step, over here we will have a positive charge because lone pair of electron takes place. In the next step, what will happen? This proton will be lost. So minus times H plus. So what we are going to get? We will get this type of species. That's N double bond C, single bond OH and single bond R. Now what will happen in the next step? Let me take the next page. So what we have generated over here, we have generated this species N double bond C, single bond OH, single bond R. So this bond will again break towards nitrogen atom. Once this bond breaks towards this side, C double bond O, that's carbonyl group is generated, and this negatively charged nitrogen atom, it abstracts this proton. So I'll show it over here. It will abstract in proton. I'll show in a single step. So what we are going to get? We get amide. So this is our N substituted. So this is our amide. So the product of the reaction is substituted amide. This is our substituted amide. So this is the mechanism of the reaction. Substituted amide is the product. Now how an alkene will react with alkyl nitrile? So let's discuss the mechanism with respect to the alkene. Now let me take this type of species. I have a alkene over here. Let me take question number 1 over here. Example number 1. I have this type of question over here. This is alkene, and in this alkene, this alkene is conjugated with carbonyl group. So it is treated with, in the first step, it is treated with RC triple bond N, that's alkyl nitride, and it is treated with H2SO4 at 0 degree centigrade. Now since this is an alkene and this is alkyl nitrile, therefore this is a Ritter reaction. Now how the mechanism will take place? Now since this H2SO4, it will provide me a proton, it's a proton source. So this bond will break. Now towards what side this bond will break? This bond will break towards this side. Why this bond will break towards this side? Because a more stable tertiary carbocation will be generated. So what will happen? This bond will break and it will abstract this proton. So what we are going to get over here, we will get a positive charge, that's carbocation, single bond carbon. This will abstract a proton and we will have double bond O and we will have this type of group. Now in the next step, what happens? Attack of this alkyl nitrile will take place. That's attack of R C triple bond N will take place. Since nitrogen contains lone pair of electron, so the lone pair of electron will attack over here. So once this lone pair of electron attacks on this side, let me show it like this. Lone pair of electron attacks on this side, this nitrogen attacks on this side, and it is bonded to carbon, and this carbon is bonded to R group. And over here we have this double bond O and this. Now since this lone pair of electron on nitrogen attacks, therefore we have positive charge over here. Now what will happen? Again this positive charge will be neutralized by shifting this double bond. So over here what we are going to get? We get R single bond C. Since this bond breaks towards nitrogen, we have a positive charge on this carbon. Again we have double bond N, and on this nitrogen is attached to the carbon. It's attached to the carbon. This carbon has two alkyl groups. Let me write these two substituents over here, and then we have this double bond O and R. Now what will happen? Since positively charged carbon is generated, therefore attack of water will take place. Now water contains lone pair of electron, it attacks over here. Again the same mechanism will take place. We will have carbon over here. On this carbon, attack of water takes place. Since lone pair of electron takes place, therefore positive charge is generated, and this is attached to this double bond N, which is attached to carbon, which bears two substituents, and rest remains same. Now what will happen? loss of H plus will take place. Now loss of H plus will take place, what will happen? This positive charge will be neutralized. So what we are going to get? We get this OH double bond N, and this is attached to carbon which has two substituents over here, and over here we have double bond O and this. Now what will happen in the next step? This bond will break towards this side, and this becomes negatively charged. It will abstract a proton, and this bond will shift over here. We get an amide over here. So what we are going to get? This is our amide. This is our substituted amide. So in nutshell, what happens? Substituted amide is formed from alkene or an alcohol. So from tertiary alcohol or an alkene, a substituted amide is formed. So this is the mechanism of the reaction. Now let us discuss certain important examples. Now let us take example number second. Let us take question number second. So I have this type of compound. This is a heterocyclic compound. So this is very important from exam point of view. So this is my example. Over here I have a substituent, that's methyl group. Over here I have C triple bond N. So cyanide is already added in this reaction. Now the reagent is given in this reaction are tertiary butyl alcohol. This is our tertiary butanol, and concentrated H2SO4. Concentrated H2SO4. And what is given? Heat is given in this reaction 70 to 75 degrees centigrade. Now what will happen in this reaction? First we have to take this tertiary butanol. So if we take this tertiary butanol, this is our tertiary butanol. Again the same mechanism will take place. This tertiary butanol will react with concentrated H2SO4, that's it will react with H plus. This H plus is obtained from concentrated H2SO4. So what will happen? This lone pair of electron will attack over here, and this will leave as a good leaving group. So water will leave as a good leaving group. We will get carbocation over here. Now in the next step, attack of this carbocation on the attack of this lone pair of electron on nitrogen atom attacks this carbocation. Means I will show it in the next step over here. What will happen is a pyridine, substituted pyridine. So in this pyridine we have methyl substituent over here, and we have nitrile over here. Now this nitrogen contains lone pair of electrons, it will attack over here. Means the substituted amide will be formed over here. So you can directly arrive at the mechanism at the answer of this section. So see how we can determine the answer of the reaction. This is methyl group, and this is our carbon. It's attached to nitrogen. This nitrogen attacks now. It attacks now our carbocation, that's 3-degree carbocation. Now what will happen in the next step? Since lone pair of electron attacks a positive charge over here, this bond will break towards this side, positive charge will be neutralized. Over here we will have a del plus, and it will be attacked by water molecule. So carbonyl group will be generated over here. So water molecule attacks over here. So what we are going to get? We are going to get this type of product. So over here we have carbon, and it's attacked by water molecule. Since water attacks lone pair of electron attackers, therefore we have positive charge on this oxygen atom, and this is attached to tertiary butyl. Now what will happen in the next step? Loss of proton will take place. Once the loss of proton takes place, what will happen? As soon as the loss of proton takes place, over here we have Me as substituent, methyl group as substituent. This Me stands for methyl group. Then we have carbon, it's attached to OH. This is double bond nitrogen, it's attached to tertiary group. Now what will happen? This bond will break, and this will abstract to this proton. This will go over here. We get a product of the reaction, that's amide. Substituted amide will be formed. So it's very important type of example which I have quoted over here. Hopefully this example you will find in your coming exams. So this is nitrogen, it's attached to this species. We have methyl group over here. So this is the product of the reaction. I'll give you over here 2 examples, and you have to tell me the product of the reaction. Now the examples are, this is example which you have to do with the help of mechanism. You will arrive at the solution of the problem. So I'll take one example. That's a very important example. I'll take very important example. Over here I have methoxy group. This is methoxy group, and over here I have this group which is above the plan, and over here I have this nitrile group. This is nitrile group. Now this is our nitrile group, and in this case we are given one more type of group, that is carboxylic group. The substituent over here is COOH, which is below the plan. Since this is below the plan, this is above the plan. Stereochemistry will not change over here once you determine the product. Why? Because you are reacting this molecule at this center. So the reaction is carried out at this center, therefore stereochemistry over here will remain same. And over here we are given one more stereochemistry, that's OH, and over here we are given pH. So in this case, intermolecular reaction will take place. Now what will happen? This is treated with acid, a very strong acid, that's trifluoroacetic acid. This is a trifluoroacetic acid, and then it is treated with water. So what will happen? Trifluoroacetic acid is a proton source. It will give me proton. So what will happen? It will give me proton. So basically this will react with proton. So first our this oxygen atom, it will be protonated, and this will be lost as water molecule. Or here carbocation will be generated. Now once the carbocation is generated, it will be attacked by this nitrogen atom. So I'll draw the product of the reaction, and you on yourself draw the mechanism of the reaction. How you will draw the mechanism? First form the carbocation over here. Then the attack of this nitrogen takes place. Once the attack of nitrogen takes place, this is a 5-membered ring. And since this is a 5-membered ring, this will be 6-membered. This will take place. This will be 6-membered. This will be 7-membered ring. So over here you will get one more ring, that will be one. This is 5-membered ring. 1, 2, 3, 4, 5, 6. You will get one more 6-membered ring. So let me number this. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. You will get one more 6-membered ring. One is this lone pair of electron attacks over here. So let me draw the product of the reaction. This is my 5-membered ring. It's attached to 6-membered ring. This 6-membered ring contains my OMe group. And over here you have a substituent, that's pH. Since this pH is below the plane, therefore one more ring will be formed above the plane. This is your carbon 1, this is your carbon 2, and this is your carbon 3, this is your carbon 4, this is your carbon 5. So this is 3, this is 4, this is 5, and this is nitrogen, it is 6. It will be attached over here. So this will be attached over here. Over here you have one more group. This group is above the plane, that is COOH. So this bond will be above the plane. This is below the plane. This will be above the plane. This again will be above the plane. So I hope you might have got how I arrived at this answer. So you have to draw stepwise mechanism of this. In case you feel any difficulty, feel free to contact me or ask me in the comment section in YouTube. Thanks for being with me. Thanks for watching this lecture. I hope you might have got this. Please share and subscribe this channel with your loved ones. Thank you.